this particular lab has an injection vulnerability, and they tell you it's in the feedback function. And through this feedback function, you should be able to execute a shell command containing the user supplied details. They don't give you which field has this injection vulnerability, but the output of the command isn't returned, so you have to figure out some other way to get the output of the command. One of the things that they do tell you is that you can use output redirection. So output redirection in the shell is done with the greater than symbol that redirects standard out from the command into a different location in the file system. So that's basically what we're going to do. And they tell you that the images are stored in var dub images, so that when you want, first you inject the command, you run it, you redirect the output goes here, and then you would subsequently access that image URL to figure out what the output was. So that's the idea of this lab. And then to solve it, execute the Unix command who am I to figure out the user account that's running the web app. So you already know, they already give you that it's in the feedback link. So that's nice. So I'm going to submit feedback, and I'm going to go here, and this is my email. And so what I'm going to do is I'm going to like, oh, you know what? I'll put the semicolon, and I'll sleep 5. Yeah, I'll sleep 5 seconds. That should be noticeable. Sleep 5, and then a subject is 495. Sleep 5, and the message is web security, and I'll sleep 5. I don't know why they would put message and pipe that into the shell, but just in case, I'm checking every single field. And and then I'm going to submit feedback, and then you're like, oh, well, I can't inject in this field. It doesn't look like, because if you look at this thing, the browser has, well, the web application has said that the kind of input that this field takes is an email. And the email has a well-formatted, well-known syntax. And so this thing is not allowing me to inject this thing into this payload. So I'm going to have to delete this in order to get this thing to actually submit. And so if I submit this feedback, it says, thank you for submitting feedback. Nothing broke. No sleep happened. But you're like, well, we weren't able to submit the sleep on the email because the browser prevented it from doing so. But we could easily send this directly to the server with the sleep command and then see if it's vulnerable to an injection attack. In fact, the web application developer might have assumed that because they couldn't inject via a web browser, that nobody could inject that shell command onto the server. And so we're gonna test to see if that is the case. So I'm gonna inspect this form again. And I'm going to look, and so this is the feedback form. It's /feedback/submit. It's a post, and it's a regular www form. There's nothing special about the encoding. It's just a regular form. It does have a CSRF token. So when I do this thing, I have to actually get this URL first to get the CSRF token. And then name, email, and subject. Name, email, subject, and message is the payload. And then I just need to submit that, and then I submitted something to this feedback form. So that's what I'm going to do. Here is the program that I'm going to run. I'm going to go and I'm going to get this URI. I'm going to copy it. I'm going to paste it in here. Get rid of this. Okay, and so let me go through this code. I'm going to make this bigger, this bigger. In case you guys are watching on your, or you guys and gals are watching on your phones. I don't know, how many of you are watching on your phones, or if you're not watching, because yeah, this is, going through code is hard unless you're watching it on a big screen. So hopefully this is big enough for you to see. So this is the site. This is the time decorator that we use for the web programming level. So there's nothing special there. And then what I'm going to do is I'm going to try the post using that string. That's the URL. That's the original URL for the main page in order to get the CSRF token, which is I'm doing here. This is the URL for the post. And then the post data has the CSRF token, has my name, and has whatever I send the try post. So try post is my function to, because I'm going to blast a bunch of these things into this route. And so the subject is, we don't have a final exam, so I can't cancel something that doesn't exist, but I'm going to post this and then and see what comes back. And so I'm not actually going to return the response because this thing will fail. Well, we'll see what this thing fails. So this is what I'm going to do. I'm going to first test the timing of the legitimate post. So in this case, I'm just doing a regular email string. And then I'm going to test the timing of the post that injects a sleep. And it'll be a 2-second delay. And you'll see this in the timing decorator. And then what I'm going to do is I'm going to try to test the timing of the post that injects this ping. And what this ping does is says send 3 pings 1 second apart to localhost. So that's what that does. So let's try those 3 first. So I'm going to run this thing. It's going to install this stuff. So legitimate post, that takes 1 second. The post that injects the sleep adds 2 seconds to it. The post that injects the ping command, so the 3 pings, and it adds 2 seconds to it. Was it 2 or 3? Well, it sends the first one initially, immediately, so then it would only be 2 seconds. Okay, so then that's where I left off in the code. So then we know that the output so if we go into var/dub/dub images and dump a file into there, we know that the images are served from this directory. And so in this case, because I have command injection, I can invoke the ls command, redirect the output to this file, and then retrieve it using this URL where the file name is output.txt. And then I can get the results and then print them. So that's what this next command is doing. I lost the output, and so you can see the ls. So there are all of these files in that directory, including the file that I just did. So this is the contents of that file. And so let me go back. The next one I'm getting here is I'm going to cat etc password and then retrieve it. So that's what this one is going to do. And then, so this is the etc password file on that container that's running there. And then you can see this actually does dump. You don't even need the who am I. Actually, this might have, did this solve the level? I hope it didn't. Oh no, it solved the level. Oh well. That's too bad. But like this gave you you could have actually dumped the shadow file. The next thing I wanted to show you is let's see. This is the so one of the ways of exfiltrating data is to do an NS lookup on a domain that the adversary controls. So I'm the adversary here, and I have this domain oregonctf.org, and I control the DNS server of oregonctf.org. And so when I look at my DNS logs, what I can do is I can say cat the etc hostname of this particular instance, and then do an NS lookup. And this will, like if I actually did this NS lookup, I will see a record of this on my OregonCTF DNS server, but I also want to, on this client, take the output. And so this is what it's taking the output of this subshell, and it's using that output as the first part of the domain name that is going to be looked up into oregonctf.org. And then I'm going to put that into this output and then dump the results of that. So that's basically what the next command is doing. And then you can see, hey, it can't find this thing. So this is the name, the host name of the server that I'm running from. And then the last one, this would solve your level as well, where you get the who am I and then you retrieve it. So that's basically, it's going to give you the same thing. And then you would see that that's the username of the file.